I'm Jonathan McDowell. I'm an astronomer at the Center for Astrophysics, working on the Chandra project. I also have a second life as the chronicler of our human effort in space, what all the rocket launches have been, what all the satellites are doing. And so I spend a lot of time talking about satellites and space policy. So I'm an astronomer working on the Chandra X-ray Center team. The Chandra X-ray Observatory is the X-ray cousin of the Hubble Space Telescope. So everyone's heard of Hubble. Chandra sees the 10% of the universe that Hubble can't see because it's gone terribly wrong. When material gets to 1,000,000 degrees, really hot, it's actually transparent to ordinary light, but it shines brightly in X-rays, and so we can see it with Chandra. And so Chandra is a 5-ton satellite that's orbiting the Earth since 1999, and we have the Mission Control Center in the Burlington Mall and the Science Center here on the Harvard campus at Garden Street.
Amazing. So in terms of space policy, space junk, what exactly is space junk? Where is it? How are we planning on dealing with it in the future? What exists at the moment? What is sort of the landscape of policy?
Right. So space junk is our generic term. The more formal term is orbital debris, right? And it is any artificial object in space that isn't doing something useful. And so when you launch a satellite, you put it in orbit around the Earth. And what that means is it's just falling around the Earth. It doesn't have a rocket engine keeping it up. And it's maybe taking pictures or relaying communications. At a certain point, you switch it off or it dies. It doesn't fall out of the sky at that point. It keeps orbiting. And so now it's space junk. When you launch the satellite, you launch it on a rocket. And the upper stage of the rocket to get the satellite into orbit also gets into orbit. And so that is almost immediately space junk if you don't get rid of it. And then there's more pathological kinds of space junk. If you have a little fuel left over in your abandoned rocket stage, 5-10 years later, the rubber separating the fuel and the oxidizer parts of the propellant might erode, and the two might mix, and you might get a large bang. And suddenly, where you had one piece of space junk, you've got 1,000 pieces of space junk all orbiting the Earth. We have also, unfortunately, space junk from collisions of satellites, and even worse, we have space junk from where people have done military tests to blow up a satellite. These are called anti-satellite weapons. You fire a missile at the satellite and smash it into pieces. And sometimes you hear people talking about shooting down a satellite, but that's a misnomer because it doesn't actually come down. The debris from the satellite stays in orbit. So that's a really unnecessary addition to the space junk environment. So the thing to understand here is that in order to be in orbit, so let me step back and talk about suborbital flights, right? So we've all seen the flights of celebrities on, for example, Blue Origin's New Shepard, which goes up into space, switches its engine off, falls back down, comes down on a parachute. And so William Shatner and Katy Perry have done these flights, right? And so getting into space isn't that hard. To get into orbit, what you do is once you're at the top point of that trajectory, you keep firing the rocket engine, but you fire it sideways on, horizontally to the Earth, and build up your speed till you're going at 17,000 miles an hour. And then you switch your engine off, and what happens? What happens is you start falling toward the Earth, but you're going so fast sideways that by the time you've traveled a mile, you've gone so far sideways that the curved Earth has curved away from you by a mile, and you're not actually any closer.
Oh.
And so you keep falling towards but sideways on to the Earth, and you keep missing it and fall all the way around. And that's what being in orbit is. But to do that, you have to be at that magic speed, right, to compensate for the curvature of the Earth. And so you have to be going at 17,000 miles an hour. And so all of the 25,000 pieces of space junk and the 11,000 working satellites that we're tracking are going at these insane speeds in low Earth orbit. in all directions in 3 dimensions, right? And so it's a kind of cosmic dodgems, where like a fairground ride where you're trying to sort of not hit each other. And so, if you get hit by even a small piece of debris traveling at 17,000 miles an hour, that's really going to hurt. And just to give an example, the worst collision we had was in 2009, when an Iridium communications satellite, American satellite, was sort of happily orbiting along, and a dead Soviet communications satellite was also going along in a 90-degree angle to it, and they smashed into one another. And so how much energy is in that collision? So I could tell you in gigajoules, that wouldn't mean anything. So I came up with this unit of a megajoule, which is how much energy is it if a 1-ton truck hits you on the road going at 100 miles an hour, right? And we can kind of imagine what that's like, and it's not fun, right? So the amount of energy in 2 half-ton satellites hitting each other at orbital speeds like that is 50,000 times more than that road collision that we just imagined.
Oh my God.
And so that pulverizes the satellites. A hypersonic shockwave goes through the satellites. The debris clouds just pass through each other and keep on going. And so that just, I think, brings home how you really don't want to be in a space fender bender. And so it's a real concern. I mean, space is big, right? But when you're going that fast, it's not so big. If you imagine, hopefully all of you who drive know that the faster you go, the bigger space you need to the car in front of you, right, to be able to react. So if you imagine if you're going down the highway at 17,000 miles an hour, you need a lot of space to be able to dodge. And more now with the increased crowding in space, satellites, which 20 years ago they didn't even bother to put engines on them. Now satellites are doing regular dodge maneuvers to avoid potential collisions with other satellites.
So as other things besides satellites enter space, so as commercial air flight, space flight becomes more feasible, more realistic, what would that actually look like? What would a potential space traffic control center, what would the rules and regulations around space? Obviously, they don't exist yet. How would that look? How should that look? Have you thought about this before?
Absolutely. So what happens right now, I mean, there's a couple things. There is law in space. There's the 1967 Outer Space Treaty. And that's actually, if you think about 1967, when it was basically the Soviet Union and the US, right, it's all written in terms of nation states launching their satellites and what their responsibilities are. So if you're a commercial company launching a satellite, you have to have a sponsoring nation state to license you. And so if your satellite hits my satellite, or if your satellite crashes out of the sky and hits me on the head on the ground on Earth, right, then I can't sue you. My government has to sue your government, and then it's between the individual governments and the people involved. And so that's the sort of slightly weird thing about space law. And the other weird thing is there's no such thing as abandoned stuff that you can salvage. So this space junk from the Soviet Union in the 1980s, we can't just go up and remove it because it's still under the, quote, jurisdiction and control of the successor state, the Russian Federation. And so you've got to get Russia's permission if you're going to go mess with their old space junk. So that just makes it all the more complicated to clean up the debris. But we are starting to experiment with space garbage trucks and removing dead satellites from crowded orbits and things like that. And I think we're going to see a lot more of that in the future. In the meantime, the de facto authority for what's going on in space is the United States Space Force. And they have radars and telescopes that report every day on where all the satellites are and what they're doing. And if they see that, we predict satellite A is going to come uncomfortably close to satellite B tomorrow at 3 p.m., what do? they warn the individual owners of those satellites if they have those owners' emails address, right? And then they email the owners and say, "Hey guys, you might be coming close." But it's not like air traffic control. With air traffic control, right? If you're in someone's air traffic control zone, the air traffic control will tell you, "Oh, you've got a potential close pass. Plane A, move up 500 feet, plane B, move down 500 feet. It's the air traffic controller who tells you what to do, not just that there's a problem. Obviously, that's not going to work with the US Space Force trying to tell, say, the Chinese what they should do or something like that. And so it's purely advisory right now, and only to those people who sort of buy into that, having a communications channel to them. And otherwise, it's just cross your fingers and hope. And so we've got to get past that, right? So we need stricter licensing on the satellites. We may need to limit how many satellites are in each orbit, which isn't a thing right now. And we need an international space surveillance network that's trusted by, it's nonpartisan, not a particular country in charge, trusted by all the different countries operating, so that eventually we can move from warnings to actual control and actual who moves first, right? Rules of the road. How close? There's been a lot of concern lately expressed by the US about some Russian satellites that are in the same orbit as a US spy satellite, and they are following somewhat close behind, but not that close, like a couple hundred miles, right? Is that too close? Is that like getting into our personal space? Or is it just fine that they're just paparazzi looking at what we're doing and there's nothing we can do about it, right? And so there's no rule that says, obviously, if you come up to like 2 feet from me going at 17,000 miles an hour, that's a bit pushy. That would probably be considered an aggressive act. 5 miles? Maybe not. 50 miles? I don't think so. And so, but there's no agreement yet. And so we've got to sort of sort out all of these rules of the road. What's the highway code for outer space? That's what we desperately need right now.
So I guess one sort of last question is, if we need a highway code, we need rules of the road, who owns the road at the moment? Nobody owns different parts of space, right? Or do they?
No, that's right. In fact, the Outer Space Treaty says that you cannot appropriate outer space or celestial bodies as a national sovereignty, right? It's not owned by any country. It's under the jurisdiction of the United Nations Committee on the Peaceful Uses of Outer Space. So it's a bit like Antarctica in that respect, not entirely. And there's concerns there because there are particular locations. So yeah, you can't own it. But say you make a base at the South Pole of the Moon. The Outer Space Treaty also says other people can't interfere with that base. So you've basically carved out a little area of the moon that's sort of, under your jurisdiction, even if not sovereignly owned by you. And so all of these things that have been very theoretical for the 60, 70 years of the space age are starting to really come home now, right? And sort of the practical implications, the legal implications are starting to push up against the very rapid pace of both governmental and commercial activity in space.
Thank you so much for your time.
You're very welcome.